So thanks for the invite to talk to you this evening a little bit more about what we've been up to at Williams Advanced Engineering in the mining sector. So I'm James Hoxie. I'm the Senior Commercial Manager for Battery Technology at Williams. So I work across a number of different markets, mainly in electrified products. I've been with Williams for just over 4 years now, and prior to that I was with Johnson Matthey, interestingly enough, where I worked with Dr. Miller actually before he was at Millbrook. So small world in batteries, as we always say, in electrification. And yeah, really pleased to be talking about what we're up to, as I said there. So just for context, I wanted to give a bit of an overview of Williams Advanced Engineering and what we do, and then a little bit of an exploration of why the mining sector is undertaking the kind of products being developed that they are, and then we'll get into some details around the haul truck electrification project that we've been working on, and then be happy to take some questions and have a bit of a discussion around what we've been doing, and then try and give a bit more clarity where needed. So from the top, I think, so for Williams Advanced Engineering, we are the engineering consultancy arm of the Formula One team. So we're based on the same campus in Grove in Oxfordshire, not too far away from Wantage, and about 20 to 30 minutes from Oxford, just to give you an idea of where we are there in Oxfordshire. We're currently 320 employees and growing. I think we've got about 30 vacancies at the moment open, so we're continually growing our business. And the majority of our projects that we've completed have been around electrification. We tend to find ourselves in projects that are generally first of a kind, and it really does leverage very often what you see in commercial motorsport. So our capabilities really are very similar to what you see on a race circuit, and it's very surprising the breadth of markets that actually touches. So really, when it comes down to it, our core competencies are around simulation, and that becomes very important in a very fast-moving world that's also becoming more and more commercially conscious. So we rely more and more on simulation activities to accelerate getting products into the marketplace, and also to reduce the cost, where appropriate at least, around physical testing. As I say, electrification, since the Kurz era of 2008, 2009 in Formula One, we've been working on several electrification topics, and fluid dynamics, lightweighting, and I think most importantly for the project we'll come into later, system integration, bringing those different electrical and mechanical disciplines together. I mentioned that we work across a number of markets, so just to give an idea of what that means, automotive and motorsport, I suppose, is where most of our customers sit. So, sort of household brands from the automotive and, if you follow it, most sports sector. But what we've found over the last years is actually that our technology transfers into the emerging markets, across mining, as a main example, also aerospace and defence, and also some really weird and wonderful products that maybe I'll talk about another time, but probably take up too much time this evening to talk about some of the really weird things that we get asked to do with some of our aerodynamics know-how. So pictorially, we end up with an image like this of the kind of products that we've actually delivered in the last 10 years of electrification, starting from small scooters, love them or hate them. You probably see them all around urban areas now, these little electric scooters that people are renting. So we've designed powertrains for the electric scooter racing series, the Brompton commuter e-bike, right the way through to the mining haul trucks that we're going to talk a little bit about later this evening. So it's quite an interesting environment that we find ourselves working in, with a common challenge around electrification. Many of these industries are looking to show the benefits of zero emissions or they're trying to get their industries to zero emissions. And typically when people come to us, it's because it's a first of a kind, as I mentioned, but also there's generally a very aggressive time frame or challenge involved. So that's kind of where we sit in the marketplace. So before I come into the sort of mining industry specifically, I think it's worth just really outlining where our pedigree in sort of electrified systems comes from. So as I mentioned, it started in Formula One with Kerr's development just over 12 years ago now. And we actually first took that technology from the racing circuit through to automotive for the Jaguar CX-75 road car product. Sadly, it didn't go into production for various reasons, and maybe, I think there's still engineers at Jaguar that would have loved to have seen this gone into production, but the stars just didn't align, sadly, for it. But we effectively took a Formula One inspired powertrain and put that into a road car. The next big jump for us was being the principal supplier to all teams on the grid for the first generation of the Formula E series, for seasons 1 to 4. And that really opened the doors for us to talk to several car manufacturers that entered teams into the series. So after that time, we started taking that motorsport derived technology towards the automotive sector initially, working with companies such as Nissan, Audi, and indeed Jaguar Land Rover. And we've continued to initiate those projects ever since, and across multiple sectors. So alongside maturing our processes to suit more stringent application areas such as automotive and aerospace, we've still continued to break records with things like the Lotus Evija battery pack design, which is a 2,000 brake horsepower hypercar that's due to go into production in the latter part of next year. So we've been sort of the main technical partner to Lotus for that product. We're now, as of last year, the sole battery supplier for, we believe, every major global electrified race series. So that's electric touring cars, or ETCR, the Extreme E, Formula E Gen 3, as it will be called, LMDH, which is the hybrid system for Le Mans and Daytona hybrid vehicles. So we really have sort of cemented our position in the area of high performance motorsport applications as our main market. And having that kind of know-how around high power focused systems, you start to understand maybe why mining operators started to take an interest in the way that we pull systems together. So really getting into the meat of the evening sort of detail and information, I think it's worth talking around what the approach is to the transformation in the mining sector. So I think it's well understood that everybody wants to do things greener and cleaner, but it's a really interesting market to actually do it in. So if you think about mining, it's a very established industry. And so effectively bringing electrification to the table is quite disruptive to the existing supply chains that are in place. So the vehicles are completely built up on diesel electric powertrains, typically. High fuel consumption, and also given some of the remote locations of the mines, actually the cost of maintaining and running the vehicles is incredibly high. So when we were looking with one mining operator as an example, effectively because of shrinkage, getting diesel to their particular mine, it worked out an effective cost of £12 per litre to get diesel to the mine. So if you sort of get upset next time you pull up at Esso, it could be a lot worse if you're a mining operator in the wrong part of the world. And they have very little energy independence. They're spending billions of dollars a year on energy. So the disruption comes from looking at things like electrical energy storage, hydrogen fuels as the main areas of interest in the projects we've been working on, and therefore being able to increase supply base or indeed get to energy independence. So whilst, you know, doing the right thing is a major part of why some of the big operators, so such as, you know, Anglo Americans and the BHPs of this world are looking at, reducing their emissions. There's also a very practical commercial reason to look at these disruptive technologies to take control of the supply chain and manage their costs more effectively. So that drive for energy efficiency creates a real need or a pull for a collaboration group. So talking about those areas, you know, the disruptors coming to the table with these technologies, they're simply technologies. So we work with the mining operators as an integrator to take and select the right technologies to effectively make sure they pick the right winners. And we work with those mining operators as their trusted engineering partner to reach that future state of a reduced energy costs and increased uptime and productivity. So sort of wanted to add a bit of colour on top of the simple, you know, doing the right thing and zero emissions, which is of course critical as we're racing towards the COP26 conference now. You know, it's just worth thinking about the other aspects at play. And so here's just a nice pictorial view of how that looks. So we effectively work on behalf of the sponsor, the mine operator, to bring those technologies together. And step one is really to get to a concept study. So when you look at a whole mine, it's actually quite daunting. Kind of what do you pick to go at first? And certainly we can't do it on our own. And so we start creating key areas to research, to model, and effectively define an approach to achieve those goals pragmatically. So pick the biggest wins first, which is why you look at things like haul trucks, because they are the biggest consumer of energy at a mine, apart from actually crushing the rock, which I've actually found out, having worked with these mining companies for a few years. Crushing rocks consumes 6% of the world's energy. So I find that an astonishing figure to take away from these conversations. You know, anything we can do to do that more efficiently would have, massive gains in sort of global energy consumption. So just an example implementation strategy that we came to, and then really it's about looking at that stepped approach around not just the haul truck and the other vehicles, but also a big part of it is the infrastructure. So these machines are, enormous, and therefore the energy required to power them. If you move to an electrically powered vehicle or a hybrid sort of with a fuel cell vehicle, you need to get a lot of energy to the mine. So there's also making sure that all the technologies are going to marry up at the right time at the mines to deliver the full system. So we look at a mine as a whole system rather than just one product. So big picture, when you think about a mine, it's not just about the haul trucks. You've also got to consider, as I mentioned, where the energy is coming from. So in the Anglo-American case study that we're going to come on to, this is kind of the actual bigger picture for the project. So delivering the haul truck is a major sort of electromechanical challenge, but also we need to, in this case, it's a fuel cell battery hybrid. So we need to produce green hydrogen. And so the route we've taken is to put a large solar array in place and an electrolyzer to produce that green hydrogen, a sufficient hydrogen refueling station, and then again looking at the excavator power station for that part of it, the shovel, the excavator, and a control center. So ensuring that the estate of different electrified products runs efficiently as possible. So hopefully that just gives you some context of where the project sits. So top level. So we were effectively engaged to develop this new fuel cell electrical vehicle, which is an ultra class mining truck. So the existing powertrain, which we'll come on to a little more detail shortly, is a diesel electric. So there's already an electric drive unit in this particular truck. And it's part of that bigger picture that I was just describing. So the battery system alone is a 1.2 megawatt hour system. And so for some context, I think an average automotive battery pack is about 60 kilowatt hours. So this is some magnitude more than a sort of automotive battery. So these trucks are very large. And effectively these have been designed and built by us to go into a mining environment. So it's a very, very different environment to that we're used to. So looking at the truck, first of all, the existing truck is a diesel powered, so it's a Cummins diesel engine, a 16-cylinder diesel unit. And as you can kind of see from the dimensions on screen in meters, it is a very large truck, capable of, I think, hauling around 290 metric tons. So these things are very large. And there's just a bit more data around on this particular truck here as well. So as I say, 290 metric tons in terms of payload capacity. So these machines, whilst they're only moving at a maximum of 40 miles an hour, they're requiring, 2 megawatts of peak power from that system. So it's an extremely high powered system. So that's the donor vehicle on the project. So thinking about the sort of classic systems engineering approach. So I'm sure anyone in an engineering environment would have seen various versions of these V diagrams. So I just want to step through each of these stages that we've been through on the project and give a bit of insight as to how we've approached that design. So first of all, really through the feasibility and concept design, we looked at those requirements, knowing that the vehicle was already driven by electric motors. The project was effectively around the blue bit. So what we've delivered here is removing that diesel powertrain and having a fuel cell module and battery pack. We had to manage the trade-off between what the fuel cell was capable of generating in terms of energy and then balance the size of the battery pack to ensure the plant had the right trade-off for 20 hours of running a day. The opportunity for sort of topping up through the day is relatively limited. So we had to work out how much hydrogen we had to be able to take on board in a given period of time and size the system accordingly. And then from a sort of electrical controls perspective for the first prototype, we had to effectively convince the existing DC-DC link up and motors that they were still connected to a diesel engine. So there was a bit of sort of additional complexity there. But I suppose really the significant unknowns for us were a major challenge. It's a classic situation with this project whereby the CEO of Anglo American have made a statement around when this truck would be running. And so we had to make our program work in that timeline. So so we had to sort of use our best judgment and simulation knowledge to ensure that the product was well engineered, was able to withstand significant shock loads. So you can imagine the sort of shock that a vehicle sees when a large amount of ore is dumped into the haul bed. It's very different to a bit of hitting a pothole or something in a vehicle. So we had to design for those kind of events, which were, relative unknowns. And moving into the more detailed design space, we got into the system layout for the battery solution, so operating at up to sort of 1500 volt peak. We took the approach to build 8 sub-packs and effectively connect 2 series and 4 parallel for those 8 sub-packs, giving you a pack and mass volume battery system level alone at, of 8,000 kilos. And actually the full drive train fully assembled is just short of 22 tons. So this is, a significantly large powertrain pulled together. So just to give you an idea of the battery solution in detailed design terms, this is sort of some steps of the assembly. We've built a number of sort of modules up here, and they effectively stack into this frame. And as you can see, again, with it being a relatively fast turnaround program, we've machined quite a robust enclosure from solid, and that stacks up to give us quite a robust looking system. So sort of eight of these go into the truck. So we've kind of got our component built up here, been through a number of tests, and sort of this is the sort of status as shared by Anglo American earlier in the year. So the packs have been shipped out. So you can see the frame on the bottom right of that sort of image on the left hand side. That's the full frame that I'm describing that weighs about 22 tons. The hydrogen production and refueling system is now in place as well. And we're finalising the tests of power electronics out in the US, and the hydrogen storage rack, which is critical for the integration as well, is well into being commissioned. So we're at a point now where all of the subcomponents are now pretty much at the end of their testing and validation, and that final integration is due to take place still by the end of the year. So as we speak, things are all making their way to South Africa for that final phase of the project. But as you can see, the truck's been stripped back and is ready to receive those components. So that's a bit of an overview of the project, gives you a bit of a view of the kind of complexities involved and the sheer scale of the system, not just from a components perspective, but actually the infrastructure that needs to be considered. And what this effectively does from a kind of powertrain perspective for the haul truck is it takes it completely into a state of an energy independence, as we mentioned. So with the hydrogen production being at the mine through the solar to electrolyzer solution, there's a complete energy independence, which is something that's actually really, really attractive for this particular mine, because the majority, I believe actually 100% of the grid in South Africa where this particular mine is located is coal. So we're kind of moving to, an off-grid situation for the energy is a good thing. It's sort of not just moving the emissions away to somewhere else, it's removing the emissions, which I think is a really positive step. I just wanted to touch on actually where we're going next. So that's a fuel cell EV. We're now actually also working with another mining operator in Australia called Fortescue Metals Group, or FMG, and we're designing, building and testing a fully EV truck for those guys. There's not as many pretty pictures to show you on that one at the moment, because this is a bit earlier in the development. But the interesting challenge for this, talking about infrastructure again, is a slightly smaller haul truck at a mere 240 tons rather than 290. It's actually, with it being a fully electric, we're developing a charging capability, getting closer to kind of 15 megawatts of continuous current to charge the battery packs in an appropriate amount of time. So again, we're looking at solving, that off-grid problem at an infrastructure level. So just a bit of an overview really of another interesting activity. So really sort of takeaway from our side is, we're very much at the forefront of these first of its kind designing system integration topics. I think the mining sector's, a really interesting study for anyone looking at kind of off-grid operations. The drivers to be off-grid will be different sectors as we see it, but certainly a lot more work to be done. I think it's very promising that, industry that's relatively cash rich, such as mining, is driving these solutions forward, and they're keen to find other adopters for it as we move into an electrified future. Greater uptake enables commoditization and driving down of costs, which is ultimately a major consideration for any business looking at these topics. So I think that's the sort of overview from my side of where the mining industry is, some of the challenges that we've seen and will continue to see. But I'm really keen to sort of open up and invite any questions and have a bit of a discussion around it, really. I think there's probably a lot of parallels that you may see in some of the sort of agricultural applications where maybe the infrastructure isn't as strong as it is in other areas. And so it'll be interesting to sort of hear your guys' views on that, and happy to take those questions now.
James, thank you very much indeed. If anyone has any questions, let's open it up to a bit of discussion. If you open your mic and put your hand up if someone else is talking first. So.
Yeah, very interesting. Thank you very much. Just a quick question. Very interested in this, particularly the hydrogen aspect. Are you looking at all at just pure hydrogen for running internal combustion engines? So you're probably aware that JCB are doing something similar. Is this something you're progressing as a option at all, or is that something that you wouldn't be doing?
So it's something that as a business we're looking at in probably slightly smaller engines than JCB possibly. But as I'm sort of thinking about the background of some of you guys, but I'm sure as Stuart will know, there's one particular OEM at the moment talking about what they're doing. I think it's pretty fair to say we're quite a large technical partner on that project. So we are looking at the hydrogen thing. And I think absolutely, in the right circumstances, you can get a similar efficiency to diesel running level. And I think the challenge that we see is we're going to have to make legislators kind of move back slightly, because you will produce some NOx emissions from a hydrogen combustion engine, be it incredibly minute. But of course, with the kind of push to electrification as the electrified powertrain is the primary route, it's created, I think, a bit of a stifle for some innovations, because it's set out some rules that are going to almost lock down other areas. But in short, absolutely looking at that as an option.
That's really interesting. I guess you're always going to have this argument, aren't you, about batteries versus hydrogen versus combustion engines, insofar that, well, batteries might be all as well, but don't forget you're having to take lithium out of the ground and mine it and extract it and all the rest of it. And hydrogen, it's there and it's ready to go, and it's a combustion engine, which we know. So I suppose there's always a trade-off, isn't there? Bearing in mind that mining's always going to be a very important sector for the world economy in terms of metals and precious stones and all the rest of it. So yeah, it's an interesting crossroads. But no, that was absolutely fascinating. Thank you very much for sharing that with us.
Yeah, pleasure.
Thank you, Tony. Tony Linfield, were you asking a question?
I was thinking along the same lines as Anthony, funnily enough, about the hydrogen side of things. But I did have one thought related to I was listening to something earlier on today about carbon offsetting and whether this type of project is entered into the carbon offsetting discussions around the world.
Yeah, I think it's an interesting one, isn't it? Because I suppose it's not the irony of what they're trying to do in the mining industry isn't lost on them, in the sense that they're trying to decarbonise taking carbon out the ground to a really basic level. I think the benefit from an offsetting perspective is the life of the mine. So the project we're working on at the moment, they believe that platinum mine's got about another 95 years left to run. So the sort of payback over a long period of time and the use of those resources is, I think, well justified in that case. I think another interesting sort of paradigm is, of course, with some of the other miners we're talking to, they're digging out those raw materials that are required to build batteries for them to then buy back and put into their own fleet. So there's a whole circular economy piece of where is that precious, material best used. So it's a really fascinating time, and I think it's, I think outcomes of this, I think the miners are going to start to understand the importance of that recycling element as well. One large car maker actually, it was actually a BMW last week, were talking about they actually believe that they're going to go straight to recycling and almost bypass the second life piece. So for quite a number of years, the whole thing with battery systems has been, we'll use it in an application and then it will become useful for a different application, and then the end of the life of that battery pack will come. And there's now a belief that actually they might just move straight to first application and recycling, because they'll need the raw material back quicker than the supply chain can scale up its capacity. There's quite a scary kind of curve of planned capacity increases in the mining sector for lithium and cobalt, nickel and so on, versus the demand for vehicles. And the mining industry can't move as fast as the automotive industry can to make the cars. So there is going to be this potential kind of knee point at some stage in the next 15 years if the recycling piece doesn't catch up, where there's just not going to be enough to go around. And so it's just a really interesting piece to work through. So going back to the hydrogen engine piece, I think there will be that necessity to say, hey, what's the best use of which technology and where? I don't really think there's an either or scenario here. I really think it's about just putting the right technologies in to the right applications. And in some scenarios, I think you can afford the inefficiency more than others. In the perfect world, a battery gives you 100% efficiency, but actually 40% might be okay if with hydrogen being so abundant, it's not such a big deal.
Yes, interestingly, hydrogen is it's certainly an area we're kind of interested in as an industry, because of its independence from power sources and time putting machines down to either charge them or to change their power pack over. And which way things go.
Absolutely. And I think from sort of perspective of your industry, I suppose, as I touched on the presentation, these guys investing a lot of money into getting that sort of heavier duty hydrogen system closer to maturity and become more economically compelling will help, sort of the adopters downstream that need a similar tech. So I think this is sort of good news to push into other heavier industries or other more, I suppose, industries that haven't got the luxury of a 90-odd year life of a mine to sort of worry about recovering their investment over. So that's a good thing.
That's certainly. Sorry, Ian. Yeah, go ahead, Ian.
Yeah. James, on the Anglo-American vehicle with the fuel cell on it, does that fuel cell provide all the power to recharge the batteries to keep the truck going for its 20-hour working day, and they just top up the hydrogen each day?
So that's the dry. Yeah, so for that particular truck, that's exactly what happens. So the big trade-off at the start of the project was around just optimizing the size of each system. So I suppose to really simplify it, the hydrogen systems aren't particularly great at kind of managing massive kind of current swings and so on. So the idea was to let the battery kind of take the abuse of the actual sort of current flow of how the truck's used, and make that battery as small as possible to ensure that it can carry enough hydrogen power on board to provide that steady, constant flow of energy into the system. So that's the way it's been designed. There are some usage cases where you probably would need to refuel during the day, but for this particular truck, this particular drive cycle, yeah, it basically runs 20 hours. Doesn't need to be topped up.
Right, that's interesting. So the battery pack is basically an accumulator pack that's being continuously charged, then discharging at a variable rate according to the duty cycle.
Yeah, exactly.
Another question, James, please. Many years ago when I worked at Cummins, who produced that V16 engine that Komatsu use, they were sort of like for diesel electric mine trucks. How mature or how advanced is the electric motor technology that they're using in there? I mean, is it permanent magnet 3-phase AC or?
So give you a bit more detail on that. So there's much more detail on this slide, not around the AC unit. So what I do know is the electric drive unit comes from GE. So the GE developed drive unit. I'm not actually sure about the specific detail beyond what's in the information here offhand, to be quite honest.
Yeah. Okay. It's just I've been looking at a job at work with what we called EPTO, which was permanent magnet AC 3-phase motors, but I wasn't too sure what technology was used in these for the motors.
I do believe in the GE solution. There is still some rare earth metals sort of around magnets and so on. But in the context of the project, we didn't really get heavily involved in the motors. They were sort of just an input we had to be aware of in terms of how much power we could send. So because we didn't specify them, it was just a kind of a set of rules, effectively at the start of the program that we had to.
Yeah.
But this truck's been in production since 1996, so I would imagine that the motors aren't particularly near, the sort of the higher end of the technology scale. What's on board?
Yeah. So, sorry, another question. Are Anglo-American looking to convert more vehicles, or is?
Yeah, so that's absolutely their intention. So that's sort of what we're in the middle of now, is working through with several operators. Actually, that bigger picture that we were talking around. So Anglo-American alone have 600 of these Komatsu trucks, this specific model. So I mean, that's an enormous fleet when you think you're kind of 1.2 megawatt hours per per truck. And there are others that buy the same equipment. Have to be quite careful what I say in this forum, but we're kind of slowly rounding up some others that may be interested in a similar solution to the same truck. And obviously the Komatsu range is goes down to an 830 and 730 as well with similar drivetrain. So it's a way that we're driving forward. And the real thing is working out the right energy mix per mine. So it comes back to the system of mines thing. So we'll probably go on a mine by mine basis to convert the fleet to either fuel cell EV or fully electric, depending on what's available. So for example, there's another mine we're looking at in Canada that is near enough next door to a significant hydroelectricity generator. So actually in that scenario, the efficiency of a fast charge is reasonably good on a full EV derivative rather than fuel cell EV. So we have to look at it mine by mine at the moment.
Yeah, okay. And are Komatsu a willing participant in this project, or are they sort of like doing their own thing somewhere else, James?
So there's been some press releases around what Komatsu are doing, working with some of the mine operators. I think that I think for us, the conversion step is an intermediate position. And then there is a kind of new platform step that comes after those conversions. So the mining operators like to run these trucks for 10 to 15 years. So there's life in converting them, it makes sense. And then there would be, what the Komatsus and Caterpillars are doing in the future, and Liebherrs and so on is looking at a future platform to sort of be a more efficient package overall. So it's similar in a way to what we saw in the automotive industry, that now, there are platforms designed specifically to be electric vehicles, whereas in the earlier days, it was an option. It was a converted version of the gasoline or the gasoline variant of the car. So I think a very similar journey that they're going to go on. I think that from the mining companies' perspectives, I don't think the big companies can move fast enough to deliver what they need by the commitments that they've made to their shareholders. So they want to go quicker than the big industry will go, I think.
Okay, thank you. Yeah.
Just to clarify, James, the truck that we're talking about here, the Komatsu, have I got it right that it's electric powered to start with a diesel generator?
Essentially, so it's a diesel traction engine sending power to an electric drive unit.
Okay, and is that done without batteries?
Done without batteries, yeah.
Okay, so what you're doing here is replacing your diesel generator with a
sort of fuel cell battery hybrid, doing the same thing. Yeah.
Interesting. How scalable do you think that technology is, coming down to maybe a farm level or much smaller quarry mine level installation? You talk about your big picture, but how small can the big picture be?
Yes, I mean you could be without too much effort, just looking at the system we've got here, we could be an eighth of the size. So we're 8 one of 8 sub packs from a battery perspective. We're 8 fuel cell modules at the moment, so you could literally make it an eighth of the size without too much effort. So yeah, it's relatively scalable. It's been designed to be modular because of the fact, I think, the operators are looking at kind of the smaller equipment as well. Some don't need the ultra class trucks, so coming down to kind of smaller dumpers has got to be something we need to be able to do, and that's kind of by design. We need this kind of toolkit. We need it, otherwise we're going to blow the business case for other things out the water. So the idea is to make the whole toolkit very scalable in the first place. So I mean, it would be interesting to understand some of the specifications of some of the sort of agricultural equipment that may be sort of worth looking at as a potential adoption case. The scalability is critical in this. Otherwise, you just introduce too much complexity into the solution. And these things, it lends itself, these things have got to be rugged and serviceable, so the haul trucks don't actually end up being fully assembled until they arrive at the mine. They're just too big to build and ship. They turn up in pieces. That's what the industry is used to. So the kit has to be rugged and easy to build anywhere in the world.
I guess in power equivalence terms, an agricultural tractor is probably about 10% of the power of this truck. You're talking 2,700 horsepower.
Yeah.
Your tractors are probably go around number 270, the top end of the
range. So if you I think you could probably get down to that denominator quite comfortably with the way these systems are built up. So I suppose the other thing is you probably need to get that electric drive as well in place. But again, there's plenty of commercially available kind of electric drive units that will probably fit the bill. And that's what we're finding in these applications. It's just trying to ensure that we don't try and reinvent the wheel, I suppose, to solve the problem when there's probably the answer on the shelf already.
Sure, yeah. Anthony Johnson.
I'm on mute. Yeah, sorry, thanks, Stuart. Yeah, I was going to ask, just looking at this and the drive motor and how it works, this looks like it's obviously going from AC to DC, and then you've got an induction motor that's being driven by a variable speed driver by the looks of it from that. Is it something that, the actual drive itself, is that something I think you probably sort of intimated the answer to this question just a moment ago, but is it more the specialism you're adding, more the sort of the battery pack, the fuel cell, that side of thing, and then the actual drive side of it in terms of the motor and the actual control system that's driving it? Is that more so the stuff that you buy off the shelf? Is that what you're alluding to? Have I understood that correctly?
Yeah, that's in this project. That's absolutely right. So what we've done is effectively spoof the drive side of the vehicle to believe it's still connected to a Cummins unit.
Yeah.
In very simple terms. That said, we do have the capability to sort of build a whole vehicle. So if it would have, looking at the future iteration, so looking at the kind of 600 trucks that need to be addressed in the Anglo-American fleet, we would need to get a bit more control over the whole vehicle to get through certain validation and certification requirements. So the sort of next generation is working with a Komatsu to effectively, get back to a steel house and then put a complete architecture into it that we can fully control and understand.
Right. Yeah, that's very interesting. Yeah.
Andy, are you?
Yeah, okay. If you go to the full electric vehicle, how does the charging work there then? You say it's got a fast charge, but how much of the working day is going to be involved in charging? Do you need to take the battery out of the vehicle to charge it?
Yes, this is the so hot swapping is definitely not an option, as we'd call it. So the battery has to stay in the vehicle.
Yeah.
There's currently some information in the marketplace that ABB have published that they're working on a 5 megawatt charger. Because of the way we're designing the system, we're able to effectively run multiples of those chargers to get to a kind of 20 megawatt charge.
Yeah.
Now, there's anyone that's an electrical guy probably find that mind-boggling because there's people in this building I'm sat in now are really having to work very hard to work out how we can do that safely. So the infrastructure piece is one element that's overcome. As I mentioned, we're very close to a lot of hydroelectricity being generated, so we're able to get the power. But actually, when you consider the sort of voltages we want to run at, there's a lot of heat to manage as well.
Yeah.
So that infrastructure challenge is enormous. And the reason I say 20 megawatts is, that's as we see it in the particular usage case of that haul truck, that there's a few opportunities in a day where you can get that charge into it. And then you haven't got to be quite so aggressive at night. For those 4 hours, you haven't got to run at the full 20 megawatts. But, during the day, the idea is you can just blast that energy in 3 or 4 times, and that should then sustain you through the whole shift. What's been really interesting in this study is it's on this project has been, you'd think you'd be able to get more regenerated energy than you can. So actually, we can get about 90 kilowatt hours into the battery pack when it runs from the top of the pit. There's an open pit mine to the bottom of the pit. That's the sort of most we can safely harness in for various reasons. Whereas there was a theoretical 150 kilowatt hours to go for. You can't pick it all up. So there's the whole efficiency case to work through properly as well. And I suppose from the opportunity charging perspective, mining works upside down where that's concerned. So the whole truck drives to the bottom of the hill, shovel loads the ore, and it drives back up. So you'd like to be taking an opportunity charge when it's being loaded. But of course you don't. It's it's at the top of the hill because it's not very practical to just move those very thick cables further and further down. So they end up at the top of the hill. And so you kind of got the whole inefficiency of charging it at the wrong point in the cycle as well to overcome. So there's a lot of really interesting infrastructure challenges there.
Okay, thanks very much.
Thank you, James. Tony Linfield, did you have something?
No, nothing more. I've just left my mic open.
Okay, fine. Apologies. I guess, James, with the boost charging that you're talking about, would you have the danger there that you would have a lot of trucks needing feeding at the same time, and therefore the whole mine would be rather swamped with power requirement?
Yeah, it's a consideration. It's certainly a consideration. I think this is why, as I say, it's an ongoing challenge we're working through. So the mine where we're going EV only, it's probably part of a mixed fleet picture in the first instance. So the level of sort of granularity we've got to there is that we know roughly when the sort of next generation or next platform of trucks will come in. That would be a fuel cell derivative. And so they're looking at the energy mix differently, and they want to prove out the technology because actually for some mines, there wouldn't be a queuing issue. And so it's kind of, there's the test bed mentality of we need to resolve this challenge. This is a good way, this is a good project to do it within. And the technology's there and ready to go. So yeah, for sure, I think the Anglo-American mine that we were talking about, you wouldn't be able to, you just simply wouldn't be able to go electric for that kind of reason, that you'd never be able to get that much power constantly into the facility. Others though you can. I think there's a whole raft of challenges. So it's also, if you have the technology available, there's things like catenary lines that you can then start to think about to then make it more efficient. So it's a whole system of things. But yeah, you're absolutely right, Stuart. It's a potentially massive infrastructure headache if you're just completely reliant on, scaling up to just streaming 20 megawatts constantly from an infrastructure perspective. Yeah.
So, kind of mind-boggling, isn't it?
Yeah.
Ian.
So on the Fortescue mine in Australia, James, what's generating the recharging power there?
So the facility in Australia, there's again a very large solar array, ridiculously large, and they've also got a reasonable amount of, we'll just call it clean energy at the moment, because I think they're due a press release on that soon, but they've got some other energy sources that they'll share. But they're also looking at ways of using hydrogen from some of their other processes to give some energy there. So there's probably a sort of mix in that scenario, but the focus is on ensuring that it's a relatively green way of using it. So what we would say as a business, as well as the mining operators, is we're trying to avoid just drawing massive amounts of coal or gas derived energy, to just provide the electricity. You're moving the problem rather than solving it.
Yeah. Okay. On some of the mines, they used to have electric loading shovels, didn't they? So like those big loading shovels that filled these haul trucks.
Yeah. So they're still very much in use. So a lot of the big sort of mining shovels are still electrically powered. So they're part of that sort of system of things. I was sort of presenting earlier this kind of picture, and the interesting thing with those, again, Ian, it's another thing we've looked at, as we call it, the battery booster pack in this slide, is when the haul truck comes to meet the shovel, is that an opportunity for that the shovel to carry a bit more energy than it needs and give that opportunity charge to the vehicle when it's down there. And I think the key for us, or the message that we give, is that we're a capable organisation. We can solve a lot of problems, but a big part of this is partnerships. I don't think there's one organisation that's going to solve every one of these infrastructure issues. And so we kind of we talk to potential partners around our kind of collated view from mining operators of this would be a really nice way of doing it. And we have to sort of alter for that technology readiness, I suppose, what's going to be available. But absolutely, you're right. There's already a lot of electrical draw elsewhere in the mine.
Yeah, I mean, when I was at Cummins, I know there was a customer that was looking at fitting their haul trucks with a pantograph to pick up off overhead power lines to give sort of like extra power to get the trucks out the mine.
Yeah.
But I don't know whether that actually came to anything or not.
Yeah, that's a thing. So that's definitely something that's happening. BHP in particular in Australia have got quite a lot of those sort of catenary lines, as they call them, running. So as the haul truck runs up the hill, which is the most energy intensive part of its life or its day, the drive unit sort of gets supplemented because they're now all these trucks are diesel electric. That pantograph effectively just tops, sort of provides a bit more power, and therefore you draw less on the diesel going up the hill.
Yeah, because going back to your previous question, Stuart, I don't know whether the technology's moved on, but 25 years ago, the biggest engine you could have with an Allison transmission for a haul truck was 1200 horsepower. So you could sort of like have an Allison automatic haul truck transmission for 1200 horsepower, and then anything bigger than that, you went diesel electric. So that tends to be why the bigger stuff was diesel electric.
Yeah, I guess you'd end up with some massive gear ratios in there, wouldn't you, if you were putting much more in?
Yeah.
I mean, to be honest, it's in terms of the combustion derived platforms, they've not changed. I mean, that's as I was sort of saying at the front end of the presentation. It's a very, very settled supply chain. It hasn't really been disrupted very much at all. So and because of that, and the consolidation, that really you've only really got Cummins, Caterpillar, or Perkins, Caterpillar. That's pretty much it. There's not really been that much drive to innovate. It's very disruptive now, sort of jumping to this technology stage.
James, what sort of area of solar panels would you be looking for to produce enough hydrogen to keep your haul truck going? You're just looking at that top right-hand picture there.
I off the top of my head, I couldn't tell you how many hectares you need, but it's suffice it to say, is quite significant. But I mean, luckily, where a lot of these mines are, there is just plenty of land.
Sure. Yeah.
I suppose in sort of agriculture, sort of just through sort of my own sort of reading and knowing of people, I suppose it's not out of the question to sort of have those sort of blended solar arrays with sort of grazing land or whatever on a farm. It depends on what sort of farm you're running or agricultural operation you're running. But yeah, I mean, you do need a lot of space to have that, to go from sort of solar to electrolyzer for green hydrogen.
So, certainly from what I've observed around here, it's very much an either or. You either grow electric or you grow animals or you grow crops. I haven't seen many installations where you can mix electric with anything else, and you know, that would lead you to a bit of a conflict, I would have thought, between an electric powered farm and the need to pardon me, the need to use the land in other ways.
Yeah, I mean, it's interesting. There's obviously people can transport anything, but that's the other sort of way of having it, is the tanks on the, on site that are topped up. That's the most efficient way of doing it, and it's the the energy independence piece, isn't it? Is you're sort of paying a supplier for a fuel, so is it okay just to pay a supplier for a different fuel, or would you want to try and control the cost a bit more yourself? It's the kind of debate you end up in or having with yourself.
Yes, and I guess if your farm is a lot nearer the infrastructure, which than your mines are,
yeah,
it changes the balance of the equation, doesn't it?
Absolutely, yeah.
Okay, and anyone else really? Any more? Well, James, thank you very much indeed for that presentation. I'll just thank you briefly here, and then we'll stop the recording. But thank you everyone for joining the lecture tonight, and James, thank you for putting it through.
Yeah, pleasure. Thanks very much for the questions as well. Good discussion. Thank you.